Hello, curious minds. Welcome back to Proving the Concept, the show where we dive headfirst into the weird, wonderful, and sometimes downright bizarre world of science and technology. I'm your host, Sarah Goffin, and today we'll be tackling something that has fascinated mathematicians, engineers, and scientists for centuries. It's a letter, it's a number, it's E! That's right, today's episode is all about E, the mathematical constant that's at the heart of decay, growth, and exponential change. From its surprising history to its impact on science and technology, we'll unpack why E is more than just a button on your calculator. And as always, we'll end with a spotlight on a trailblazing female scientist who has contributed to this fascinating area of study. So settle in, it's going to be exponential. At its simplest, E is a mathematical constant roughly equal to 2.718. It's an irrational number, meaning it has an infinite number of non-repeating decimal places. But what makes E so special is its relationship to exponential growth and natural logarithms. Here's a quick thought experiment. Imagine you have $1 and you're investing it in a magical bank account with 100% annual interest. If interest is compounded once a year, you'll have $2 at the end of the year. But if it's compounded twice a year, quarterly, or even continuously, the amount approaches a limit. And that limit is E. In other words, E is the number we get when we calculate 1 plus 1 to the n, all to the power of n, as n approaches infinity. It's the mathematical embodiment of growth that feeds on itself, a cornerstone of calculus, and the key to understanding natural processes. The story of E begins in the 17th century. While exponential growth and compound interest had been studied for centuries, it wasn't until Swiss mathematician Jacob Bernoulli investigated compound interest that E began to emerge. Bernoulli stumbled upon E while calculating how interest grows when compounded an infinite number of times. But Bernoulli didn't actually define E. That credit goes to Leonhard Euler, another brilliant Swiss mathematician. Euler introduced the symbol E in the 1730s and was the first to study its properties in depth. He showed that E was deeply connected to logarithms, calculus, and even trigonometry. Fun fact, Euler loved E so much that he used it to define exponential functions like e to the power of x and linked it to imaginary numbers in his famous equation e to the power of I pi plus 1 equals 0. It's considered one of the most beautiful equations in mathematics, combining 5 fundamental constants in a single elegant formula. Now that we know what E is and where it comes from, let's look at where it shows up in the world. Spoiler alert, it's everywhere. Science and nature. E models processes like population growth, radioactive decay, and cooling. It's also used to describe the shape of a hanging chain, called a catenary curve, and the spread of diseases. Engineers use E in control systems, signal processing, and even artificial intelligence. Anytime we deal with rates of change or optimization, E is likely involved. And as we mentioned earlier, E plays a key role in compound interest and models market behaviours like inflation and investment growth. And fun facts, did you know that E is part of your DNA? The structure of genetic mutations over generations follows patterns described by E. Or that E is critical in the world of gambling and gaming, helping calculate the probabilities and payouts. Finally, let's shine a light on a pioneering female mathematician whose work touches on this fascinating topic, Sofia Kovalevskaya. Sophia was a 19th century Russian mathematician and the first woman in Europe to earn a doctorate in mathematics. While she didn't explicitly work on E, her contributions to differential equations and analysis are closely tied to its applications. One of her most famous achievements was the Kovalevskaya top, a special type of spinning top that uses partial differential equations in its analysis. These equations often involve exponential functions and constants like E. Sophia's groundbreaking work laid the foundation for many of the tools we use to study change, growth, and decay in physics and mathematics. Beyond her research, she also broke barriers for women in academia, proving that intellectual brilliance transcends societal boundaries. And that's it for today's episode of Proving the Concept. We explored the wonders of E, its history and its many applications, from science and finance to nature and technology. We also celebrated Sofia Kovalevskaya, a trailblazer whose work continues to inspire mathematicians around the globe. If you enjoyed this episode, don't forget to subscribe and leave a review. Got a question or a topic you'd like me to cover? Reach out on social media or via email. I'd love to hear from you. Until next time, stay curious and keep proving the concept.